Okay, this is the second part of Lesson 2, Roman numeral 7, Miscellaneous Substitution. This one is probably the most exciting, I think. I like this one the best. It's pretty fun. Theorem. It's worth memorizing this theorem. We're going to prove it later in the video, but at first we're just going to use it. So if u equals the tangent of x over 2, so if you let that be true, for negative pi is less than x is less than pi. If you let that substitution be true, then several things occur. Then the sine of x becomes 2u over 1 plus u squared, and the cosine of x becomes 1 minus u squared over 1 plus u squared, and finally dx becomes 2 over 1 plus u squared du. It is worth committing that to memory. You only want to use this if you need to, because it is rigorous. You will see in the examples how that comes into play. Again, we're going to prove that if this is true, then this is true, but first we're just going to utilize it. Let's take a look at example 1. Okay, in example 1, we have 1 over 4 sine of x minus 3 cosine of x dx. Again, I would explore other ways before trying this. It turns out this is the method to use for this particular problem, but I would have tried something else first, and looking at this, there's nothing really I don't know to try. So, the whole idea here is we make these substitutions. We say, let u equal the tangent of x over 2, and begin to sub away. So we have the integral. Okay, so dx is going to be this expression over here. So we have a 2 du, and that's going to be all over, but I'm going to write it like this. 1 plus u squared. Okay, so that's just taking care of the dx. So now 4 sine x becomes 8u over 1 plus u squared. That's because I made the substitution here. Minus 3 times 1 minus u squared over 1 plus u squared. Like that. Okay, let's continue on. This is awesome. Anyway, what does this simplify to? This becomes 2 du over, now I'm going to distribute this to both terms. So I have left 8u minus 3 plus u squared. I should leave you alone now and integrate away, because this is partial fractions. And we have 2 du over actually, looks like I need a 3 down here. Yep, because it is 3 distributed. Sorry about that. So du over 3u squared plus 8u minus 3. There it goes. Continuing along, this is going to be 2 times the integral of a du over 3u minus 1 plus, I'll put a bracket here, plus the integral of b du over u plus 3. I'll let you work out the details, but that comes out to be a is 3/10, b is equal to negative 1/10. So this becomes 1/3 times 6 over 10 times, natural log of 3u minus 1, this is just natural log, minus 1/5 natural log u plus 3 plus c, which then equals 1/5 natural log 3u minus 1 minus 1/5 natural log u plus 3 plus c. We can combine these and say 1/5 natural log 3u minus 1 over u plus 3 plus c. And finally, we want to sub back, so we have 1/5 natural log 3. Now, u equals the tangent of x over 2 minus 1, like that, all over the tangent of x over 2 plus 3 plus c. Man, that's a fun one. Try that again. Do it without the video this time. In example 2 of the section, we have the cosine of x over 1 plus the sine squared of x dx. At this point, press pause, see what you can do, see what kind of fun you can have. And then come back to me. Okay, the kind of tricky here and sort of evil, you would have tried some substitution and it had been a real big mess. But the truth is, this one is actually an easy substitution. So I tricked you. Because you should always try something else first. If you simply let u equal the sine of x, then du is the cosine of x dx. And after our substitution, we simply have 1 over 1 plus u squared du, which is the inverse tangent of u plus c, which then is the inverse tangent of the sine of x plus c. Pretty easy. Okay, this is the last part, Roman numeral 8. This is table of integration. I won't be assessing your ability to use the table of integration. It would more be about proving one of the items on the table of integration. You find the table of integrations in the notes or the homework of the PDF attached to the video. This is for x greater than 0, this is dx, and this is for x greater than 0. The idea, it's a brief table of integrals, brief meaning 140 plus integrals to look from. So you would see an integral like this and go to the table excuse me, of integration and find one that fit this form. You might want to press pause, find the table of integration in your book or in the notes, and see if you can figure out which number of the 140 plus would apply here. If you press pause, then come back. Turns out that it's number 27. So number 27 is dx over x squared times the integral of a squared plus x squared, and that comes out to be negative radical a squared plus x squared over a squared x plus c. So ours fits this form, so we're ready to do it. I would say here that a squared is equal to 3/5. A squared is equal to 3/5. And so this integral here becomes 1 over the square root of 5, integral of 1 over x squared times 3/5 plus x squared dx equals negative 1 over radical 5 square root of 3/5 plus x squared over 3/5 x plus c according to this above. Now that does end up simplifying nicely to be negative square root of 3 plus 5x squared over 3x plus c. Now, if you were asked to integrate this initially in a bubble, you probably would have tried integration with a trig sub, and that would have worked. This is just an alternative, just exposing you to the table of integration. And the last one here, if you're asked to integrate this, I certainly could use integration by parts. Tabular integration would be the best fit, but let's see if you can't find some items on the table of integration that would help you to solve this. Otherwise, take a look at the table. You need several of them actually, and it turns out that you would need 81, 80, and 79 from the table of integration. So this would equal, according to each one of these, x cubed sine x minus 3 times the integral of x squared sine x dx. That's one item. This is similar to using like a reduction formula. The table of integration is a set of rules that you can use to integrate. So using the next item on the integration table, excuse me, x cubed sine x minus 3 times negative x squared cosine of x plus 2 integral of x cosine of x dx. Simplify here, x cubed sine x plus 3x squared cosine x minus 6 times, let's integrate that, would be cosine x using the next item on the integration table plus x sine x plus c. Once you distribute this, you have your final as such. I will finish the video now with the proof of the theorem used earlier in the lesson. Okay, so I'm going to let u equal tangent of x over 2 for x between negative pi and pi. Now I'm just going to write some items here. The cosine of x over 2 is equal to 1 over the secant of x over 2. Definition equals 1 over the square root of 1 plus the tangent squared of x over 2. That's just an identity for secant squared, which then equals 1 over the square root of 1 plus u squared. To the next line, the sine of x over 2 is equal to tangent, well, if I had tangent times cosine, that would also give me sine. So tangent of x over 2 times the cosine of x over 2, which would be u times 1 over, we already established what the cosine was above, 1 plus u squared. Now, using an identity, we can say that in general cosine of x is equal to 1 minus 2 sine squared of x over 2. So that would give us 1 minus 2u squared over 1 plus u squared, which then common denominator would simplify to 1 minus u squared over 1 plus u squared. Cha-ching! Next, using another identity, the sine of x is always equal to 2 sine of x over 2 times the cosine of x over 2, which gives us 2. Now we established what the sine of x over 2 was above, u over radical 1 plus u squared, and then we established what the cosine was just earlier, 1 minus u squared over 1 plus u squared, and then that simplifies, but I made a mistake. The cosine of x over 2 is actually above here, so that's times 1 over the square root of 1 plus u squared. That's what I want, because then that's going to simplify to be 2u over 1 plus u squared. Cha-ching. Good. That's what we wanted. And then finally, if u is equal to the tangent of x over 2, then x equals 2 inverse tangent of u, and dx equals 2 du over 1 plus u squared, the final cha-ching. That should conclude the lesson.